Everyone. So let's begin with today's problems. The first problem, the first problem states that there are n nails driven into the wall. The ith nail is driven ai meters above the ground, and one end of the bi meter long rope is tied to it. All the nails hang at different height, one above the other. One candy is tied to all the rope at once. Candy is tied to end of a rope that is not tied to the nail. So we need to find how many ropes we need to cut minimum so that we can lower the candy to the ground. Okay. So let's consider an example. Let's consider this first test case itself. The first test case says that there are three nails. One is present at a height 4, one is present at height 3, and the other is present at height 1. And there are three wires attached to them respectively, one of length 3, one of length 1, and the third one of length 2. So which all row do we need to cut so that the candy reaches the ground? In this case, we can see that if I do not cut the rope attached with the pin 4, and if I cut all other ropes, then my candy will still be 1 meter above the ground because the height of the pin is 4 and the length of the string is equal to 3. Similarly, if I do not cut this one, my candy will be 2 meters above the ground in this case. However, in this case, the length of the string is equal to 2. Okay, so the candy can always touch the ground since the length of the string is 2 and the pin is only 1 meter above the ground. So what can we observe? We need to cut all those ropes whose length is less than the height at which the pin through which it is attached is present. Here in this case, since 4 is greater than 3, we need to cut this rope. Here 3 is greater than 1, we need to cut this. And in this case, 1 is not greater than 2, so we can leave it as it is. So in this case, the answer is 2. So let's have a look at the code. So here's the code, pretty simple. We'll take the value of n as input, that is the number of pins, and the height at which is present and the length of the string attached to it. And if the height at which the pin is present is greater than the length of the string, then we need to cut it, and we increment our count by +1. And at the end, we print the total number of strings we need to cut, which was stored in the variable count. So now let's begin with the second problem. So the second problem states that Rudolph invented the game of tic-tac-toe for 3 players. It has classical rules except for the third player who plays with pluses. Rudolph has a 3x3 field. The result of the completed game, each field cell contains either a cross or a naught or a plus sign or nothing. The game is won by the player who makes a horizontal, vertical or diagonal row of three of the symbols. So Rudolph wants to find the result of the game. Either exactly one of the player wins or there is a draw. It is guaranteed that multiple players cannot win at a time. Okay. So how should we proceed in this case? So we can simply take the brute force approach, in which, for example, if I write down the first test case, I will check each row for, let's assume I begin with the symbol plus. I will check whether plus is present in the first row. I'll check whether plus is present in the second row, in the third row, similarly in the first, second or third column, or in the 2 diagonals. If I do not find it, then I'll begin with the cross, and even in this case, if I do not find it, then I'll check with the naught. And if in all 3 cases I find that none of them follows the condition, then the answer will be draw. Okay. So let's have a look at the code. So here's the code. I took the 3 strings corresponding to the 3 rows as input in an array called A, and then split that array into a character array of size 3 into 3, 9 elements. And I stored the string in the form of a 2D character array. And I've made a checker function which checks whether the given pattern is present for a given character or not. So what is the pattern? The pattern is that that the character should be present in a row or in a column, in all the elements of a row, in all the elements of a column, or along the diagonal. So simply a for loop can be used to check the 2 conditions, and the 3rd condition I've checked it using the brute force manner. And if any of these conditions becomes true, then return true, otherwise finally it will return false. I have checked it for cross, then for 0, and then for plus, and if none of them satisfies, then the answer is true. So let's begin with the 3rd problem. The 3rd problem states that Rudolph has registered for a programming competition that follows the ICPC rules. So the rules imply that for each problem, a participant gets 1 point and also incurs a penalty equal to the number of minutes passed from the beginning of the competition to the moment of solving the problem. In the final table, the participant with the most point is ranked higher, and in case of tie in points, the participant with the lower penalty is ranked higher. So it has been said that there is a powerful artificial intelligence bot that can predict which player can finish which problem in how much amount of time. Okay, and Rudolph is player number 1, and the competition lasts for h minutes. Rudolph realizes that the order of solving problem will affect the final result. For example, if h is 120, then solving the first problem first and then the second problem would incur a penalty of 55, whereas solving the second one before first would incur a penalty of 50. So we have to find if all the players play optimally, then what is position at which Rudolph will finish. Okay, so what should be a first motive? Our first motive should be to maximize the points of each player. In this test case, we can see that to solve the first problem, the first player needs 15 minutes. The second problem, the first player will require 15 minutes, and then the third problem 110 minutes. Okay, and the competition will last 120 minutes, and we know that the player with higher points will finish at a higher position. So what should be our first priority? We should solve all those problems which require less amount of time to be solved. Okay, so in place of solving the problem which requires 110 minutes, it is more optimal if I solve the other 2 problems which will require only 35 minutes. And select. So what should we do? We should sort the array of times and select all those problems whose sum of time is less than the total time h, starting from the beginning. Okay, so in this case, if I start from the first element, I'll take 20. After 20 minutes, I'll solve the first problem. Again, when I move to the next element, my current time is 35, and I've solved 2 problems. However, by the time I reach the 3rd index, my time exceeds 120, so I cannot get this point. So I cannot solve the 3rd problem within the time limit. Okay, so first thing is that we should sort it on the basis of time and select as many number of problems which I can solve within the time limit. And okay, so once I'm done with that, I know which all problems I'm going to solve. Assume that there are 3 problems that I can solve within the time limit. and they have times A, B and C respectively. Okay, so let me assume that I solve the problem that requires B time first. So I'll be able to complete it within B time. After that, I decide that I'll solve the problem which requires A time. So the current time is B plus A, and this will incur a penalty of B plus A. The first problem will incur a penalty of B. And after this, if I decide to solve the problem C, then it will require a total time of A plus B plus C, also incurring a penalty of A plus B. So if I sum up the penalties, I can see that it is equal to 3B plus 2A plus C. So to make this expression minimum, what should be my order of times of ABC? We can say that the time required to solve B must be less than the time required to solve A, must be less than the time required to solve C. Okay. So what can we do? We can arrange the elements based on the time, and then we can first find out the number of maximum points that I can achieve. And once I've achieved the maximum number of points, I can again iterate from the start and calculate the penalty incurred at each index till the index I can score. Okay, so let's have a look at the code. So this is the code for the third one. First, I've taken N, M and H as the input and stored them, and have created an array of size n into 3. This will store the 3 indexes are corresponding to points, penalties and then the index, because I need to sort the array, and the initial order in which the elements were given might get shuffled, and so to find the position at which Rudolph finishes, I need this index variable as well. So I'll first start from 0 to n, and I need to take the input of the m times. Okay, so I'll simply take the input and sort the array based on the time, and I've created 3 variables: point, time and penalty. Okay, so and I begin from the 0th index until the mth index, and until time plus the time required to solve the next problem is less than the total time of the contest, I can consider that I can solve that problem within the time limit. So I will add that variable in time. I'll increment the points variable by +1, and penalty will increase by time. How? We can see that the total time required to solve the problem is the time it contributes in the penalty. So simply if I add the value of time in the penalty, that will give me the total penalty I'll incur to solve that many number of problems. And after that, I'll save these 3 variables, the point, penalty and the index, in the array created before this one. And after that, I need to sort the array. So how should the sorting be done? So the first preference should be the points. The one with higher points must be placed above this condition. And if points are same, then I should sort it based in increasing order of the penalty. That is, the lower penalty will be at top. Okay. So I've sorted it, and then I've traversed on the entire array and find out where 0 is present, because Rudolph is present at position 0, was initially present at position 0, and in this array the index 0 will be present at that location where he finally finishes. So I'll simply find that index and print I plus 1 because of 1 based indexing and then break out of the loop. So this was the solution to the third problem. So let's begin with the fourth problem. Okay. So it states that Rudolph drew a beautiful Christmas tree and decided to paint the picture. However, the ink in the cartridge often runs out at most inconvenient moments. Therefore, Rudolph wants to calculate in advance how much green ink he needs. The tree has a vertical trunk which doesn't have any thickness, and the tree comprises of isosceles triangles whose base is of length d and height is h, and the bases are present at some indexes which are provided as input to us. Okay, so what do we need to do in this case? We know the size of each of the isosceles triangle. So what can be the possible cases? It can be a case that the two isosceles triangles do not overlap. In this case, both of the triangle will contribute to the total, will contribute as much area they cover. Okay, so let its area be x. So in this case, the total area contributed would be equal to 2x. Okay, so and what can be the other case? The other case can be that two triangles overlap with each other. So in this case, the total area contributed would be 2x minus this overlapping part, let's say p. Okay, so what can we do? In which cases will there be an overlap? We can say that if we start from this y coordinate and up to y plus h, there is no triangle which has its base within y to y plus h, then we can say that it follows this condition. If the next triangle has the y value of the base less than y plus h, then there is overlap. Okay, so so what should we do? So if the y value, so let's assume that we are starting, the bottommost triangle has a y value of 1 and the height of each triangle is 3, and next triangle is present at some height 4, let's say 4, and the other is present at a height 2. Okay, so if this was the case, then I can simply add the entire area of the first triangle into my answer. Okay, and if this is not the case, then I need to subtract something. So how much should I add? So let's take an example. So if the two triangles are present somewhat like this, okay, and this is the amount which is overlapped. Let's assume this height as x and this height would be h minus x. Okay, so can I find the area of this part, this segment only? I know the base as d and the height of the entire segment as h, and since this is a triangle, I can simply say that h by d equal to uh, x by this length, let this be L, x by L. So I can calculate L from here. So L would be L would be equal to um, x into d by h. Okay. And how can I find x? X is simply h minus the difference between two consecutive triangles. Okay, difference between the heights of two consecutive triangles. So if this is present at y1 and this is present at y2, then x would simply be equal to h minus y2 minus y. Okay. So I can say that the bottom triangle is contributing to half into sum of parallel sides, that is d plus L into h minus x area. And the uppermost triangle is providing the entire area. Okay. So this is how we can calculate the total area. So let's have a look at the code. So here's the code. First I've taken n, d and h as the input, and I've stored the base height at which bases are present in an array ARR. Then I've sorted the array ARR and initialized answer with the height of the triangle, with the height of one triangle. Why? Because while I'm iterating upwards, I'll be checking for the difference between two consecutive triangles. So I would never find any triangle above the last triangle to take difference with. So I have iterated from 0 to n minus 2 and taken the difference with the next element. So let's assume I ranges from 0 to n minus 2. So the I plus 1 would range from 1 to n minus 1. Okay. So I'm never considering the last triangle's area while calculating the value. So I need to add it at first, and then I'm iterating through the array and calculating the difference between the bases of two triangles. If that difference is greater than h, I can simply add the entire area of triangle to the answer. And if not, I need to find the value of x and calculate the area as I've derived the formula here. So half into sum of parallel sides into the height. And finally, I've printed the answer. So let's have a look at problem E1. So here's the problem E1. So it states that one morning Rudolph was looking thoughtfully out of the window watching the falling snow. He quickly noticed a certain symmetry in the configuration of the snowflakes. And like a true mathematician, Rudolph came up with a mathematical model of the snowflakes. Okay, so how is the model defined? The graph, it is defined as a graph, and the graph has initially only one vertex, and then more vertices are added to the graph. The initial vertex is connected by edge to k new vertices. Here in this case we can see that 1 was the initial vertex, and then the value of k was equal to 4, and we connected 4 other vertices to it. And each vertex that is connected to only one other vertex is connected by edges to k more new vertices. This step should be done at least once. Okay, so after connecting k edges to one, we have to connect k more edges to each of the new node that I joined currently. So this should be done at least once. So this is the smallest graph that is possible for k equal to 4. Okay, so we are given a number n, and we need to find whether it is possible to uh, we need to check whether such a graph can exist or not for any value of k greater than or equal to 2. Okay, so what can we do in this case? We can simply see that let's take general value of k. I have one node initially. After that, I connect k other nodes to it. After attaching k nodes to it, each node can be attached to k other nodes. Okay. So after each level, what is the total number of nodes? After only the central node, it was 1. After the central one and one layer, it was 1 plus k. After the second layer, it becomes 1 plus k square. After the third layer, it would become up to k cube. So we can observe that if there are n layers in total, if there are p layers, let's say p layers in total, so there would be, so the number of nodes would be simply equal to this sum. From 1, the sum of the GP from 1 to k to the power p. So we can k to the power p minus 1 because the central one is considered as the first layer. So there would be p elements in this total. So what can we write this equal to? We can write this equal to k to the power p minus 1 by k minus 1. Okay. And we are given that the value of n is less than or equal to 10 to the power 6. So we can also say that the value of k will also be equal to less than or equal to 10 to the power 6, because in each layer I am adding at least k of these edges, k of the new nodes. So if I add, and if my value of n is less than k, if my value of n is less than k, then I would definitely not have an answer, because after adding the first node, if I add k more nodes, then k plus 1 would be surely greater than n. Okay, so we can say that k is definitely less than n, and the minimum value of k can be 2. So these are the possible values for k. Okay, so what can we do next? We have to check whether we can have n. We can create a GP whose sum is equal to n and the common ratio is equal to k. Okay, so since the value of k lies between 2 to 10 to the power 6, since n is 10 to the power 6, we can always iterate over each of the k's and check for the result. So if k to the power p exceeds 10 to the power 6, then definitely I won't get an answer. So what can be the maximum value of p? I can simply put k equal to 2 and calculate this. Okay, so I can see that p, I'll not get an answer in this case. So 2 to the power p must be less than or equal to 10 to the power 6. So in this case, p will be less than or equal to log of 10 to the power 6 to the base 2. So log of 10 to the power 6 to the base 2. Okay, so if we calculate this, this would probably be around 20. So what can we do? We can iterate over all k's from 2 to n and iterate over all p's from 20 from 1 to 20. Okay, and check whether that is equal to n. And if that is equal to n, then we can say our answer exists, otherwise not. And the time complexity would be equal to 20 into n. And since n is 10 to the power 6, this will surely pass. So let's see the code. So here's the code. I've iterated k from 2 to n, and I've calculated that if 1 plus k square is greater than n, since it is said that there should be minimum 2 layers present, that is, we cannot have a graph of this kind in which there is only one layer, that is the central node, and one layer outside that. This is not possible. There should be at least 2 layers. So the value of 1 plus k square should be less than or equal to n. Okay. So if 1 plus k square is greater than n, then we can simply break out of the loop. Otherwise, I can iterate from 3 to 21, because there should be 3 to 21 number of layers that is possible, and can calculate the sum of the GP using the formula. And if that is equal to n, I can set the variable b to true and break out of the loop. And at the end, if I get a value of b, and if any value of k and j makes the variable b as true, then finally I can print yes, otherwise I'll print no. Okay. So let's have a look at problem E2. So this is the exactly same problem. This is exactly the same problem, but the constraint on n goes to 10 to the power 18. So definitely big O of n solution won't work, and we need to find something in log n time for this same question. Okay. So what can we do? We had seen that since the value of k ranges from 2 to, in this case, let's say up to 10 to the power 18. For now, let us assume that the value of k ranges within these two numbers. Okay. So what is the maximum number of layers that I can get? That would be equal to 2 to the power x. Let us assume that value as x equal to 10 to the power 18. Okay. So using this, I can find that the maximum number of layers is somewhere around 60. Fine. So since the maximum number of layers is equal to 60, now we can find a value of k for a given value of x. So what I'm saying is that I'll assume that I have a graph which has let's say p layers. Okay. And I'll try to construct it using the value of k from 2 to 10 to the power 18. So what I will try k to the power p minus 1 by k minus 1 equal to n or not for some value of k. Okay. So for a given value of p, I can say that beyond a certain limit, beyond a certain value of k, this value will always be greater than n, and below a certain value, it would always be less than or equal to n. Okay. As I keep on increasing k, this value will increase, and at one point it might become equal to n, and after that it will stay greater than n for sure. Okay. So what can I do? I can simply iterate over all values of x and use binary search on the value of k. I can iterate on all values of p and use binary search on value of k to check whether the nearest value of this expression is equal to n or not. If it is equal to n, then I can say that I found my answer, and if not, then I can select a different value of p plus 1. That is, there is one more layer, and repeat the same process until I find my answer. Okay. So here's the code. So I've simply taken the value of n as input and set the variable b initially to false. This b variable will finally store true if the answer is possible, else no. Okay. So since minimum I need to have 3 layers, and since n can go up to 10 to the power 18, so there can be 60 layers in total. 62, I've assumed that 62 layers in total. So I've iterated on each of these layers and set the value of low to 2 and high to 10 to the power 18 by I minus 1. Why so? Because the only thing here is that I need to avoid overflow of variables. Okay, so if my k value is equal to 2, then I can say that 1 plus, if my I value is equal to 3, okay, so 1 plus k square, the first sum of first 3 elements, must be less than or equal to 10 to the power 18. Okay, it doesn't make sense if this variable itself processes 10 to the power 18, because I need a minimum of 2 layers to get the result. So that is why I have selected the value of high as this one. And how I've calculated this? I've simply ignored these two values and checked that k to the k square is less than equal to 10 to the power 18. Because if this is true, then this will also be true, and k would simply be less than equal to 10 to the power 9. Okay, so I can set the value of k equal to 10 to the power 9 in case my I value is equal to 3. That is, I need the sum of first 3 numbers. Okay, similarly for the next case, I can see that k cube, when I equal to 4, k cube would be less than or equal to, should be less than or equal to 10 to the power 18. So the value of k would be less than or equal to 10 to the power 6. Okay, so I've used the value of high as calculated from this expression, calculated mid, and checked if 1 plus mid square, the sum of first 3, exceeds the value of n. However, this check is not required because I've already decided the value of high as such that this will never be true. Okay, and I need to calculate the sum of this GP. So how should I do it? It can be the case that while adding 1 plus k square up to the ith term, I go beyond the limit that a long variable can hold. So at each iteration, I am beginning with 0. After first iteration, I'll multiply it with k, that is the value of mid, current k, that is the value of mid, and I'll add 1 to it. So after first iteration, my value of that loop is 1. After second iteration, I'll again multiply this by k and add 1 to it. So my value is k plus 1. The third case, I'll multiply it with k, so k square plus k, and add 1. I'm doing this step by step because it may be the case that till going up to some index, there might be an overflow. So I am calculating the value of n. I'm storing that value of the sum of that GP in the variable val. If at some time it exceeds n, then I can simply break out of the loop. Or if adding the next element would make the value greater than n, or the next element itself that I'm going to add in this GP is greater than n, then I'm not adding that value and I'm breaking out of this loop. Okay. In both these cases, I can say that what would be the answer? What would be my sum of the GP? That would be something greater than n for sure. So I'm putting that value equal to n plus 1, and then I'm breaking out of this loop. So if my value equal to n, then I have found my answer. Else if it's less than n, then low equal to mid plus 1. And if it's not, then I need to decrement the value of high. And if b is true by the end of all this iteration, then I'll print yes, otherwise no.